Today in class, I introduced the idea that a mole was really a bundle of atoms, a very big bundle of atoms, or at least a bundle of a lot of atoms. A mole is equal to 6.022 times 10 to the 23rd particles. In this video, I'm going to discuss how we convert between mass, volume, and moles. So what's the relationship between this bundle of atoms that we call a mole and the more familiar things like mass and volume that we can measure in the lab? So if we're going to be figuring out how to convert between mass and moles, we have to ask ourselves the question, what is the mass of 1 mole? The answer is it really depends on the substance, but I want to remind you of something I said in the last video, which is that 1 mole of protons is equal to 1 gram. That's how we defined Avogadro's number. We wanted to make sure that 1 mole of protons was going to be the same thing as 1 gram. Well, that means that 1 gram is the same thing as 6.022 times 10 to the 23rd protons, because a mole of protons is 6.02 times 10 to the 23rd protons. And that also means that since a proton has a mass of 1 AMU, that means that 1 gram is the same thing as 6.022 times 10 to the 23rd AMU. So some of you may see where I'm going with this, but I want to do a few examples just so we can see more clearly. If we ask ourselves what is the mass of a mole of magnesium atoms, we can use these conversion factors up above to give us the answer. If we have 1 mole of magnesium atoms, well, 1 mole of magnesium atoms is 6.022 times 10 to the 23rd magnesium atoms. So now that we have our answer in magnesium atoms, we need to be able to go between magnesium atoms and mass. Now, if you'll remember, if we look on the periodic table will give us the atomic mass of the atom in AMU. So if we pull out our periodic tables and we look at the block for magnesium, we will see that 1 magnesium atom is 24.3051 AMU. But let's say we want to express our mass in grams. We can then use this conversion factor. 1 gram is 6.022 times 10 to the 23rd AMU. Now what we'll see is we can cancel out our units, and then we're going to have our answer in grams. But we also have this factor of 6.022 times 10 to the 23rd that's at the top of our equation and at the bottom of our equation. So really, when we go and type this into our calculators, we don't have to bother with the 6.022 times 10 to the 23rd at all. We have 1 times 24.3051 times 1 gram divided by 1 divided by 1. So the mass of a mole of magnesium atoms is 24.30 grams. Now notice, since I only know Avogadro's number to 4 sig figs, I can only express my answer to 4 sig figs. But other than that, my mass of a mole of magnesium atoms is the same thing in grams as my atomic mass is in AMU. Let's see another example. What is the mass of a mole of iron atoms? Well, if we have 1 mole of iron, that's equal to 6.022 times 10 to the 23rd iron atoms. Now, if we want to convert to mass, we go to our periodic table, we look up the molar mass of iron, which is 55.845 AMU. And since we now want to express our mass in grams, since it's the mass of a mole, 1 gram is just the same as 6.022 times 10 to the 23rd AMU. So again, we can cross out our AMUs, we can cross out our atoms, We can cross out our moles. And since 6.022 times 10 to the 23rd is both on the top and our bottom, we then are just multiplying 1 times 55.845 times 1 divided by 1 divided by 1, and rounded to 4 sig figs is 55.85 grams. Well, that is very interesting. The mass of the mole of any atom, which we call its molar mass, is just its periodic table mass expressed in grams. So this is just a function of the way we defined a mole. If the mass of an atom is 55.845 AMU, then the mass of a mole is 55.845 grams. So we can say that the mass of a mole is the same as the periodic table mass expressed in grams. We don't have to do any calculation, okay? So that is the molar mass, and that's going to become very useful. We don't have to do any of these calculations anymore to figure out the mass of a mole. Just look at your periodic table and we can also find the molar masses of compounds. The molar mass of a compound is just the sum of the molar masses of each atom. So let's say we want to find the molar mass of magnesium chloride. Well, all we do is we go to our periodic table, we look up the molar mass of magnesium, and we look up the molar mass of chlorine. The molar mass of magnesium, if we look on our periodic table, is just 24.305 grams. The molar mass of chlorine is 35.453 grams. We multiply that by 2 because there are 2 chlorines. We add those together. We get that the molar mass of magnesium chloride is just 95.211 grams. So if I have 1 mole of magnesium chloride, that's just 95.211 grams. Well, what I have now is a conversion factor between grams and moles. What this is really saying is that 1 mole of magnesium chloride is equal to 95.211 grams. So if I have a question like this, how many moles of magnesium chloride are there in 14.6 grams? Well, I can start with my 14.6 grams, and now I can convert this into moles because I have a conversion factor that says that 1 mole of magnesium chloride has a mass of 95.211 grams. When I multiply those together, 14.6 grams is 0.152 moles. Remember, a mole is just a bundle of atoms or a bundle of molecules. If 1 bundle of magnesium chloride weighs 95.211 grams, then if I have 14.6 grams, that's the same as saying I have 0.152 moles. And then, if we want to figure out how many moles of chlorine atoms are in this, well, I can say I have 0.152 moles of magnesium chloride, and then I just got to convert magnesium chloride into chlorine. The ratio between magnesium and chlorine is 1 to 2. So 1 mole of magnesium chloride is 2 moles of chlorine, and that's saying I have 0.307 moles of chlorine in my sample. If I want to figure out how many magnesium atoms are in this sample, well, I start with my 0.152 moles of magnesium chloride. Then I've got to convert that into moles of magnesium. So 1 mole of magnesium chloride is the same as saying I have 1 mole of magnesium. And then I convert that into magnesium atoms. 1 mole of magnesium is just 6.022 times 10 to the 23rd atoms. That's equal to 9.15 times 10 to the 22 atoms of magnesium. So what I'm able to do using this dimensional analysis is I can weigh something in the lab, and then I can figure out how many atoms are in it. So that is a very powerful thing to be able to do. So far, we'll just do a different type of problem here. Let's say I have a sample of lithium hydride. Let's say I weigh that sample of lithium hydride, and it's 16.43 grams. So if I want to figure out something about the atoms in that sample of lithium hydride, I can convert between mass and moles using the molar mass of lithium hydride. So if I have 16.43 grams of lithium hydride, I've just got to add the mass of lithium to the mass of hydrogen, and I end up with 1 mole of lithium hydride is 7.95 grams. Then, what I've essentially done is I've said that I've tried to convert the mass into these bundles of atoms that I call moles. So if you do the math in your calculator, you'll find that 16.43 divided by 7.95 is 2.1 or thereabouts. So really what I'm saying is when I weighed out that 16.43 grams, I have 2.1 bundles of atoms. That's equivalent to 2.1 bundles of atoms. Well, then if I want to know how many atoms, I have to figure out how many atoms are in one of these bundles. So I can convert between moles and number of particles using Avogadro's number. So if one bundle of anything contains 6.022 times 10 to the 23rd of that thing. Now for lithium hydride, I'm using the word formula units rather than molecules. You will see that sometimes. Really what I'm saying is that when lithium connects with hydrogen, since this is an ionic compound, I don't have individual lithium hydride molecules. Instead, I have a crystal lattice. So whenever I'm using an ionic compound, I never use the word molecule, I use the word formula units. But anyway, what I'm really saying is that 1 mole of lithium hydride is 6.022 times 10 to the 23rd lithiums and 6.022 times 10 to the 23rd hydrides. So when I do that math, that's saying I have 1.24 times 10 to the 24th formula units. So in this sample of lithium hydride, I have 1.24 times 10 to the 24th lithium atoms and 1.24 times 10 to the 24th hydrogen atoms. So this is a really useful tool. Now what I am able to do is I'm able to go between a sample that I can measure in the lab, and I can just right off the bat, after a few calculations, tell you how many atoms are in it. So that is a very powerful tool. But what if I record the volume instead of the mass? That introduces another level of complication, right? I don't exactly have a molar volume. So how can I figure out how many atoms are in a sample of liquid if I've just recorded the volume, if I haven't measured the mass? My strategy here is to see if I can convert the volume into a mass. So I need some conversion factor between mass and volume. If I could convert mass into volume, or sorry, volume into mass, then I'd be able to go back up here and convert the mass into moles and convert the moles into number of particles. Now that can be an issue though. How can I convert mass into volume? What relates mass and volume? We're looking for something that gives us the amount of mass in a given volume. We have learned how to do this. The answer is the density. Remember, the density is how tightly packed something is. Okay? So it's the amount of mass packed into a given volume. So if you take 1 milliliter and you look at the amount of stuff in it, something with a high density is going to have a lot of stuff packed into that volume. Something with a low density is not going to have a lot of stuff packed into that volume. So if I want to know the mass of 25 milliliters of ethanol, if its density is 0.789 grams per milliliter, that means that 1 milliliter of ethanol weighs 0.789 grams. So this density is really a conversion factor between mass and volume. So if I start with 25 milliliters, I'm saying that 1 milliliter is 0.789 grams. So I got to think about this density as a conversion factor. 0.789 grams per milliliter means I have 0.789 grams in 1 milliliter. So my 1 milliliter goes on the bottom, my grams go on the top. So then when I cancel out my units, I have Sally on the top, I have Sally on the bottom, I have milliliters on the top, milliliters on the bottom. Those cancel. My answer is in grams, which is the unit for mass. So if you've written this correctly, that should always work. So that's 19.7 grams. What is the volume of 15.0 grams of carbon tetrachloride? The density of carbon tetrachloride is 1.59 grams per milliliter. Well, first, let's write 1.59 grams per milliliter as a conversion factor. All right, now we can go ahead. We start with the 15.0 grams, and then we say 1.59 grams is the same thing as 1 milliliter. That's equal to 9.43 milliliters. Now let's get fun. 40.0 milliliters contains how many moles of dichloromethane if the density of dichloromethane is 1.33 grams per milliliter? I start with my 40 milliliters. Then I've got to convert milliliters into grams. So let's see if you can write me the conversion factor to convert milliliters into grams. That's 1.33 grams in 1 milliliter. Now I want to convert to moles. So how can I convert to moles? Write me the conversion factor that's going to go grams into moles. Well, I have 1 carbon and 2 hydrogens and 2 chlorines. So my molar mass is just the expression 12.01 plus 1.008 times 2 plus 35.45 times 2. And then if I add that together, that's going to be my molar mass. You can leave it unsolved in your equation. But what you need to do, though, is you need to make sure you have parentheses around this when you type this into your calculator. But anyway, when we do that math, we end up with 0.626 moles. And then finally, for our grand finale, 125 milliliters of pentane contains how many carbon atoms? So we have 125 milliliters. We need to convert milliliters into grams. So write me a conversion factor for that. 0.626 grams per milliliter. Now we need to convert grams into moles. Write me a conversion factor for that. So that's 5 times 12.01 plus 12 times 1.008 grams in 1 mole of pentane. And then we need to convert moles of pentane into moles of carbon, right? Because the question asks about carbon. So 1 mole of pentane is the same as 5 moles of carbon. And then we need to convert moles of carbon into carbon atoms. And to do that, we use Avogadro's number. So when all is said and done, 125 milliliters of pentane is 3.27 times 10 to the 24 carbon atoms. So again, we can pour a volume into our graduated cylinder, and using this calculation, we know exactly how many carbon atoms are in it, which is pretty neat, up to 3 sig figs anyway. I hope that all made sense. I will see you next class.